Hey everyone, I had a few people that had questions on some of the problems in 10.1, 10.2, so I am recording just a couple of videos so that hopefully I can walk you through the steps on this type of question in the homework. This type is the question where you have a long list of data with X variables, which are our explanatory or independent variables, and then Y are our response variable or dependent variable. So the first thing you want to do here, the question is, what value, predict the value for the explanatory variable for the x that will give you a value of 124 on the response variable, or the y. So what that's saying is, when y is 124, what is our x value? What can we predict using our linear model here? And so the first thing we want to do is go to Stat and Edit. And I've done this ahead of time, so you don't have to watch me type all these numbers in. You want to type in all of your X in L1, all of your Y's in L2. And then we go to Stat Calc, scroll over and down to number 4, linear regression AX plus B. And on this calculator, I'm not sure if they all work the same, but on this calculator, I have to tell it to use list 1 and list 2. So that's where my data is sitting. And it comes back with a linear regression. So here I'm looking at a y equals ax plus b, where the a is negative 3.151487671, and our b, or our y-intercept, is 205.470612. We are not concerned with the correlation coefficient here on this specific problem. All right, so I'm going to set that up, and I've typed this into a Word doc so that hopefully I can make this clear. So we have this y equals ax plus b, and we're looking at the information that we have from our calculator. So our question is telling us that our y value is 124, and we want to predict what x will be. So we're going to plug in everything we know. We're going to substitute in 124 for our y. Our a is given on the calculator is that negative 3.15149. And the b is 205.4706. So the only variable we have left to solve for is that x. We think back to algebra. If we're adding 205 on the right side to get x by itself, we want to subtract 205.4706 from both sides. That gives us negative 81.4706 is equal to negative 3.15149x. At this point, we're multiplying by x, so to undo that operation, we want to divide both sides by negative 3.15149, and that gives me a 25.85 on the left-hand side, equal to x. And this question is asking to round to one decimal place, so I'll round that to 25.9. So those are the steps I would walk through in order to solve, and so I'll put 25.9 here. And hit enter, and hopefully we get green. Yes, we do. Wonderful. So that's how we want to tackle this problem when we have a long list of data. The next question I have here is finding the line of best fit through a set of data where you have y equal to negative 43.195 plus 3.044x. So instead of ax plus b, in this case, they did the b first plus the ax. But they've already given you the equation. So really, we just have to read really carefully, and it says, according to this equation, what is the predicted value of the dependent variable? Again, we're looking for y, when the independent variable has value 70. So we'll do the exact same thing that we just did, except now we're given the formula. So really, we're just putting 70 in here and looking for what comes up with y. So I'll take 3. Oh, hold on, got a 7 in there. So I'll take 3.044. I'm going to multiply that by the 70 that they gave us. And then I can either add, or really in this case we're adding a negative, so add or subtract here, 43.195. And that should give us our response. Oh, I did the wrong. Okay, I know what I did. So let's try this again. 213.08. I used the wrong negative here. So I'm going to do a plus. And then in parentheses, I probably used the minus instead of the negative there. 43.195. And I can see 169.885 says to round to one decimal place, so I'll put in 169.9. There we go. All right, so in the first scenario, we had a big long list of numbers we had to put in first to get the linear regression. In the second question, we're given the linear equation, and we're just substituting in either the dependent or, in this case, the independent variable.